Hi everybody. Today we are going to be talking about absolute value and distance. We're doing lesson 4-7. This is the last lesson for this module. So we're going to be talking once again about the coordinate plane and looking at distance between points. So there's two different ways we can find the distance. One is horizontal distance, right? So that means going this way. Or we can find vertical distance, which is up and down. So either way, we're going to be talking about those two distances. So in order to find horizontal distance between 2 points, they would have to have the same y coordinate. And then what you're going to do is then find the distance from one to the other. So when we watch 2 points, or when we have 2 points that are on the same quadrant and they have the same y coordinate, we subtract the absolute values of the x coordinates to find the distance between the 2 points. So in this case, if we have -5, -4, -5, -4, and -1, -4, okay, we can then find the absolute values. The absolute value of -1 would be a +1, and the absolute value of -5 would be 5. And then if we did 5 minus 1, we would then end up with 4. So the distance between the 2 points is 4 units. So we can also just go ahead and take a look. If we're looking across the line here, 1, 2, 3, 4, we can see that it is 4 units from one to the other. So basically you're finding absolute value and then adding or subtracting depending on the signs. So if this one, in this case, this would be where we have different signs. So once again, we would find the absolute value of the x coordinates. -4 would have an absolute value of a +4. 1 would have an absolute value of 1. And because the signs were different, we have a negative and a positive, we actually add the values. 4 plus 1 is 5. So the distance between these 2 points would be 5 units. Now, let's talk about it in the quadrant, same quadrant, which is what we did with our first one. So find the horizontal distance between 2 points. We're going to first identify the ordered pairs for u and v. U, we would have 1/2 and -1/2 as our ordered pairs. -1 and 1/2. Then we would take a look at v. We have our x coordinate as a 2 and the -1 and 1/2. Now, because our y values are the same, we're going to look at our x values and find the absolute values of those and then subtract. The absolute value of 1/2 is 1/2. The absolute value of 2 is 2. Then we subtract. 2 minus 1/2 is 1 and 1/2. So u and v are 1 and 1/2 units apart. All right, let's practice with our check. Once again, you're going to go ahead and pause the video and see how you do on this, and then you can compare your answers to mine. So the first step, though, is to find your ordered pairs. P, the ordered pair would be -5, -2. Q is a -2, -2. Then you want to find the absolute value of -5, which is 5. The absolute value of -2, which is 2. And then subtract to find your distance. 5 minus 2 is 3. We would label this units. So 3 units would be the distance from P to Q. Now, here we go, practicing it in different quadrants. We're finding it from E to F. Once again, the first thing we do is identify its ordered pairs. Now, because each line here, we have 2 spaces between 0 and -0.5. This would be -0.25. This would be -0.75. Each line is worth a fourth, basically. And -0.25. F would be a +0.25 and a -0.25. So our y's are the same. So we're going to compare the x's. So first thing, finding the absolute value of this would be 0.75. Absolute value of this, 0.25. And then we add them together. 0.75 plus 0.25 is a positive 1. So U and V are 1 unit apart. Once again, let's do our check. Same thing you do. Pause this and see how you do, and then we will compare. So our first step is to identify the ordered pair. K would be a -2, +1. L would be a +1, +1. Then, because our ones are the same, we're going to find the absolute value of -2, which is 2, the absolute value of 1, which is 1, and because they're in different quadrants, we add them. 2 plus 1 is 3, label it units. So the distance from K to L is 3 units. Now, let's do the same thing, but talk about it vertically. So one on top of the other. If it's in the same quadrant, same rules still apply. Same quadrant, we subtract. Different quadrants, we add. So now, when we look at 3, -1, and 3, -5, our 3's are the same, so we don't want to worry about that. We want to look at what's different. So start by finding the absolute value of the different ones, which is our y coordinates here. Absolute value of -1 is a +1. Absolute value of -5 is a +5. Same quadrant, we subtract. Now, different quadrants. Look at what's the same. Okay, we don't want to worry about that then. We want to take a look at this. So find the absolute value of our different values. -4 would be a +4. +1 has an absolute value of 1. Different quadrants, we add. 4 plus 1 is 5. So our distance between those 2 points is 5. Now let's go ahead and try some examples on page 249. So following along. So the x coordinates, so here we have the vertical coordinates between, or vertical distance between points D, -1 and 1, -1 and -1/2, and C, -1, -2. Now, because they're both negative, negative, remember we can use our notes that we have. Negative, negative means they are in quadrant 3, right? So they're both in the same quadrant. Find our absolute values. Absolute value of -2 is a +2. Absolute value of -1/2 is a +1/2. And because they are in the same quadrant, we subtract. Okay, so when you subtract, you would get 1 and 1/2 as your distance. Now, once again, we're going to take a look at these two. Here we take a look, the x's are the same, so our y's are what's different. We're going to find the absolute value of -1 and 1/3, which is 1 and 1/3. Oof, I can write. Absolute value of -2/3. Oopsie, sorry, there we go, is 2/3. Because they are in the same quadrant, right? They both have negative negatives. We subtract. 1 and 1/3 minus 2/3 would give us 2/3. So 2/3 units would be your answer for this problem here. All right. Let's take a look at example 4. Now looking at different quadrants. So when you have S and T, okay, positive, 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 negative. So positive, positive would be here in quadrant 1. Positive, negative would be in quadrant 4. So we're moving from this quadrant, from this quadrant down to this quadrant, finding the difference there, distance there. So finding your absolute value of the different numbers, right? Our ones are the same, so we're going to compare these, find the absolute values of those. Okay, so we have 1/2 and another half. 1/2 plus 1/2, because they're in different quadrants, we add. We would then find that they're 1 unit apart. Okay, take a look here. Different quadrants because we have positive, 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 negative. Okay, so quadrant, this would be quadrant 1, this would be quadrant 4. Okay, We know then different quadrants are where we add. So find your absolute value of the different numbers. Absolute value of 1.5 equals 1.5. Absolute value of -2 is 2. Then we add 2 plus 1.5 equals, 2 plus 1 is 3, and we still have a half. So the distance would be 3.5 units. All right. Last thing we have is our reply here. It says Fritz and Manolo like to skateboard together at a nearby park. They want to determine who has to walk the farther distance to get to the park, so they graph the locations on a coordinate plane, with the city's main square at the origin. The coordinates for each location are shown in the table. Each unit represents a city block. Who has to walk a farther distance to the park? So here's the park, okay? So what you're going to do is find the distance from Fritz's house to the park and from Manolo's house to the park and determine who has a further distance. As always, go ahead and give this a try and email me your answers. All right, that is our final lesson for Module 4. As always, if you have any questions, please let me know, and I will do my best to help you out with that. Please remember to complete your assignments on McGraw-Hill, and if you need help, make sure to attend those Google Meets. If there's anything else, let me know. Have a great day.